Welcome. For your Lysozyme lab report, you're going to have to do some manipulations of your data in Excel, and there's a couple of tricks that will make this process a whole lot easier for you. So what I want to talk to you about today is your selection of graph type, the use of the $, which is a very handy tool to make these calculations go really, really fast. A problem that you are going to get for sure when you try to graph data according to the instructions I gave you, which is a transposition issue, and that doesn't have anything to do with genetic material or music, and how important it is to have consistent ranges on your y-axis. Well, let's just sort of go ahead and start. Here is some data that's based loosely on last semester's data, and this is a lot like what your data is going to look like, you know, as you have the different columns that correspond to the different trials, plus the column of times. So this data that's shaded here and this in light blue is primarily the data that we're going to look at. Okay, I have discovered that it's very convenient to grab the entire block, including these headings. This seems to have worked very nicely for me when I was working with these data. You hit insert to make your graph, and you always choose the scatter. And for this particular data, you can go ahead and choose this option that puts smooth lines through all the points. You do not expect a linear trend line. The relationship you're going to be graphing here, there's no basis for assuming it's going to be linear or exponential or anything else. However, you do expect a gradual decrease. So plain old scatter is good, but you can use the smooth lines through the markers one as well. And I mentioned to you, never use something that's just lines with no markers, because the markers are your data, and you need to show those in the graph. So we're going to choose this, and oh my goodness, what is that mess? That doesn't look like anything reasonable. Okay? Well, the problem is that even though you've got what is a column of X data and a bunch of columns of Y data, Excel sees that you've got more things going this way than you do up and down, and it decides, no, the numbers across the top are X, and the things going, that this would be your X data, and these will all be different different rows of Y data. So what do? Right click on here and hit select data. Okay. Here's all your different series, which when we get a little bit farther, those will go away and be replaced by actual letters that identify the trials, which is nice because series doesn't mean anything. Don't worry about that right now. Here's the business part you want. Switch row and column. Okay. Here's the problem. Excel thinks that your data is in rows instead of columns. So you say, I'm going to switch those. And here's your column headings, and hit OK. And it looks like something. You've got your optical density readings on the y-axis, which you will, of course, add labels to, and you have your time on the x-axis. Okay. That takes care of graph type and the problem with transposition. If you have too many columns compared to the number of rows, then Excel's going to switch the rows and columns on you, and you have to go back into the menu and tell it to switch it back the way you want it. Alright, the next problem is the calculation that you have to do. As you can see looking at this graph, this starts up here and goes down across here, this starts here and goes straight across, and they cross each other, and it's a little bit of a jumble, and it's sometimes really hard to see it very clearly, to see what's going on. Because really, if you want to compare a bunch of things, it really helps if they all start in the same place. So we're going to do something which in a general sense is referred to as normalizing the data. That is, we're going to do a mathematical operation that sort of equalizes the starting point of all the numbers. Well, how can we do that? I'm going to just move this out of the way for now. I'll delete it later. Well, if we can look at the change in each one, if we look at A1 here, it starts off at 0.593, and then it changes from there. This one starts here, changes from there. We can compare how different the optical density readings are compared to the initial one at time 0 before any damage occurred to the cells. In order to make all the numbers look like that, we divide all the numbers in the column by the starting OD, the one at 0 time. Okay? So, first thing I'm going to do is copy and paste the numbers here, the times, and put those here. And now we can enter a formula, and the formula is as follows. We want to divide the first cell, which happens to be B2, by B2. Okay? Because we're going to say we started at 1, and then everything else is a fraction of that. Do you remember Hardy-Weinberg in genetics where everything adds up to 1 and the frequencies are all less than 1? It's kind of like that. Okay. Now, I'm also going to make these all 2 decimal places. Make it number format, 2 decimal places. Good. Okay. That's going to make the data look much prettier. Okay, so we did the first one. We divided this number by itself, and now we want to divide all the rest of them by this. But we can't just copy and paste, because what it will do is divide each number by itself, and we get nowhere. Okay, so we want an easy way to always divide each one of these numbers by the first one. And the way we do that, we come up here. We want to stay in what we want to do. We're in column B, and we're going to copy and paste this to the other columns. But we want to always go back to the row 2 and always divide all the numbers in each column by that first one, which happens to be in row 2. We can pin that by putting the $sign there. So that each time we copy and paste this, it will go, it will be in whatever column it's in. That can change, but it will always go back to row 2 and divide by the number at 0 time. Okay, that still, of course, means this number divided by this number, which is 1. Any number divided by it's the same number as 1. But now we can copy and paste this, and now our numbers are changing a little bit. Not only that, this is B. If we just copy it to the next column, now we'll get C, but each time it will go back to the first number in row 2 and divide by that. So we can actually take this, copy it, and in fact, we can paste it everywhere. I love this. Bink. All your calculations are done like that. Okay. So just always check your work. Always check your work. Every 0 time starts at 1, and then if the ODs are going down, your fractions should also be going down. If they're staying about the same, they should stay about the same. Everything makes sense. Always check to make sure that your answers make sense. Okay, and then when you, we can also copy and paste these headings, and now we can make a new graph, and you're going to have to do the transposition thing again. Insert, scatter, smooth line, ugliness, make ugliness go away. Right click on the graph, hit select data, hit switch row column, and then OK. And that's the kind of thing that your graph should look like. Okay. Notice they all start at the same place, so it's much easier to compare them than it would be if you have lines going all higgledy-piggledy everywhere. And we can take this one and just, I'll say it, go away. Oh well. There we go. Don't forget to put axis labels on here and identify the axis correctly. These numbers up here are optical density. If these are optical density, these aren't. You've changed them. Make sure your y-axis labels are appropriate. The final thing I wanted to point out is that when you graph all these data like this, Excel pretty nicely gives you a range from 1 down to 0, and they all have the same scale. Alright, well, what if we decide we are going to just graph these data here? Let me go ahead and pull these down to here, and I'll pull the time down, copy this and set it over here, because you always have to have your X data next to your Y data. And what did I do? Okay, sorry. A little bit stupid there for a second. We got to copy and paste these as values. Apologies. There. Okay. Now let's graph this. Insert, scatter, smooth lines. Wow. Okay, this is kind of a funky looking graph here. And it's like, wow, these numbers went really down. No, they didn't. This really ugly, bumpy red thing here is exactly the same as this orange line up here. This looks like it did something. This clearly shows you it didn't. Look at this y-axis scale. Okay, this is very misleading. This looks like something happens when you see the same graph on a different scale. You see that there's virtually no change at all. This is why it's really important whenever you graph groups of data that you're going to compare that the y-axis range is the same on all your graphs, so you can visually look at one graph to another and see what's going on without being misled. Okay, that's all I have for you. I hope that little tutorial was helpful and that you will have an easy time doing your lab report.